In this video, we're going to cover proportional relationships. Let's begin. A relationship between two quantities is proportional if the ratio between the quantities is constant. And when we talk about quantities, we're talking about like things that you can measure, like miles and hours, miles and time. Money is a quantity, something that is measurable. So miles would be distance, any kind of distance. Hours would be like a kind of time, so any kind of time. Money, weight is measurable, so that would be a quantity. So when we have like something like miles per hour or dollars per hour or dollars per pound, those would be two things that would be compared. Those would be two quantities. We'll talk about what it means to be constant in a moment, but two things will be true about a graph that is proportional. So we're going to focus on graphs, and also we're going to focus on tables. So let's focus on the graph first. You may want to underline graph for this one. You'll know a graph has a proportional relationship if it is a straight line. Not just straight, because not all straight lines will be proportional relationships. It also has to pass through the origin. And the origin is 0.00. So if you see a graph that not only is a straight line, but passes through this point, then you know it is a proportional relationship. Or you know that you have a proportional relationship. So in a table, so like this would be a table right here, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y over x will always be constant. So this one is going to be trickier. You have to check the y over x ratios and see if they are equal every time. Let's try this story. Hillary is looking for a gym to join. One gym offers a membership for $25 a month. Use this information to complete the following. Well, at 0 months, how much does she pay? Well, she doesn't pay anything. At 1 month, she pays 25. At 2 months, she pays 50. At 3 months, she pays 75. How do I know this? It's, basically I'm multiplying by 25. So 25 times the number of months, 25 times 2 months, 25 times 3 months, 25 times 4 months, that equals 100. And then this would be 25 times 0 months, which equals 0, of course. So at X months, how would I figure it out? Well, take a look at what I did here. 25 times 0, 25 times 1, 25 times 2, 25 times 3, 25 times 4. How about 25 times X? Now, you don't want to say, you don't want to do times X because that looks like 25xx. So normally when you multiply 25 in a variable, you just 25x. Like that. So what would the cost be? It would be 25x. So what is the slope or rate of change shown in the table? Well, the slope or rate of change shown in this table is going to be 25. That's the rate of change. It changes by 25 every month. Sorry, it's kind of an ugly 5, but it's okay. You could also say $25 is the rate of change. Is the table proportional? Explain. Let's actually get to that question afterward. We'll talk about whether relationships are proportional afterward. Let's just go to the graph. So using our graph of values, create a graph to show the relationship. So at 0 months, which is down here, so this, let's label this. This is the number of months. We need to label it months. And this is our money, dollar amount. So at 0 months, we pay $0. At 1 month, we pay 25, which is greater than 20, less than 30. So it's like right there. At 2 months, we pay 50, so like right over here. 3 months is 75. 4 months is 100. And if we draw a line through that, we do get a straight line. Well, I didn't do a very good job of drawing the line through my points. It's not a very straight line either, but close enough. So we do have a straight line. And does it pass through our origin, which is kind of the two things we need? We need a straight line. Does it pass through the origin? It does. So it is a proportional relationship. Looks like I skipped the first question. What is the slope or rate of change shown in the graph? Well, if you remember, we could take the points, this one, and let's do this one because it runs through a corner, and we do rise over run. Our rise is, it's not 5, it's 50, and our run is 2. So it's 50 over 2, which is just 25, right? And isn't that the same as the table? It is. Look at that. All right, we asked if the graph is proportional, and we said yes, because it is a straight line, and it does run through the origin. So yes. Why? Two things. Number one, line is straight. Actually, I'm going to say, yeah, line is straight. Number two, passes 0.00, which is down here. All right, now let's talk about the table and whether it's proportional. What you want to look for is you want to see if y over x, and our y is going to be our dependent variable. Our cost is dependent, our time, number of months, is independent. So y over x. We can't do 0 over 0, so kind of skip that. Well, we need to have 0 over 0, but also we need 25. Our x is 1. 25 over 1 is just 25. We have 50 over 2. That also equals 1. Sorry, 25. 75 over 3. Does that equal 25? It does. 100 divided by 4. Does that equal 25? Yes. So yeah, if you look at all these points, 25, like 125, 250, 375, 4, 100. If you divide the y value by the x value, you end up with the same answer each time, which is 25. So is the table proportional? Yes. And you would say because y over x is constant, it's the same each time. It's not like I divided this next number and then I got like, 35 or something like that. Let's go ahead and try some other, going further, equation. So write an equation to represent the relationship between x, the number of months at the gym, and y, the total cost of the membership. So our dependent variable, which is the cost is 25 times the months, right? Times the number of months. Times the months. So if y is the cost, which is the dependent variable, 25, they say x is the number of months, so it's y equals 25x. That is our equation. Do you see the slope in the equation? If so, where? The slope, remember, we said the slope or rate of change is 25. Yes. Yes, we do. It's multiplying. It's multiplied with x. It's multiplied by x, or you can say it's the coefficient, if you remember what that word is. Coefficient of x. So coefficient is just the number in front of x. It's the number in front of x. What conclusions can we make about proportional equations? Well, we can say that in an equation, the slope will be the coefficient in front of x, which is basically what we said. In the coefficient in an equation and we're talking about this. This is our equation. In an equation, slope is the coefficient of x. Coefficient of x. All right, so in equation, now we know how to figure out proportionality in an equation, or we will be. So proportional equations will be written in the form of y equals mx, where m is the slope or rate of change. What do the x and y represent in the equation? Well, the x is it's the different input and output that would make the ordered pairs. So you could say it's the dependent and independent variables, dependent and independent variables. You could also say it's the input and the output. So dependent is y, the x, that's x. This is the output and input values. So don't worry so much about this question. If you get it, great. If not, try your best to wrap your mind around it. Number 1, the table below shows the cost of a certain number of pounds of apples. Again, in a table, independent usually goes first, y or dependent goes next. So, the cost of the apples depends on the number of pounds, right? 1104, that depends on how many pounds. So, what is the slope or rate of change? Well, we can figure out the slope or rate of change by doing, remember, y over x. So, any y over x, you can choose this point or this point or this point or this point. I'm going to choose the first one. The numbers are smaller, so let's do this point, which is 4 and 5.52. So y over x is 5. The y is 5.52. The x is 4. And if we divide that, 5.52 divided by 4, we get 1.38. What does this mean? 1.38 is the cost per single apple. So this is the cost per apple. Is the table proportional? How do we know? Well, we don't know yet. We need to actually divide all of these. 11.04 divided by 8, so I'm going to calculator that. 11.04 divided by 8. So let's do this. 11.04 divided by 8. That gets me 138. Let's do 1656 divided by 12. So 1656 divided by 12. I got 138 again. And finally, let's do 2208 divided by 16. And I also got 138. Bleeds into my next box. So, we can also, so we figured that out. We figured all that out. The y over x of all of these is 138. So it is proportional. Write an equation for the table. So this is how we know. It's because we did y over x each time. Write an equation for the table. The equation is going to be y equals mx. And m is the slope. Our slope is 138x. And that's it. All right. Let's take a look at number 2. Use the graph to answer the questions. What is the slope or rate of change of this line? Well, let's choose 2 points that run at corners. This is 0, 0. And the next corner is this one. It looks like 0.3 and 4. 0.34, because remember, look at this. This says 4, even though it's only 2 up. So what is the slope or rate of change? What I need to do is look at the rise over run, or do the slope formula. So if I do slope formula, I could do, remember this is, this is y2, sorry, this is x2, and this is y2, and this is x1, and this is y1. So I could do 4 minus y1, which is 0, and then 3 minus 0, and that equals 4 over 3. Or it's 1 and 1/3. It actually doesn't matter which one you decide to go with. I think I'm going to go with 4/3. Or you could count the rise. The rise is 4. The run is 3. You know, you could have done it either way. Is the graph proportional? How do I know? Well, remember, is it a straight line? Yep, looks like a straight line. Does it run through 0, 0? Yes. Again, 1, straight line. IG8 line. 2, passes 0, 0. Write an equation for the graph. Remember, it's y equals mx. So y and x, that's, you know, it's going to be like that the whole time. What's the m? The m is the slope. Our slope is 4/3. Or you could say our slope is 1 and 1/3 as well. They both are fine. And I believe that's it. So now we know how to determine proportional relationships in equations. This is a proportional equation that shows a proportional relationship because it's y equals the slope and then x. We know how to find it in a table. We just do y divided by x each time and see if you have the same answer each time. You get the same slope each time, and it is the same slope. And on a graph, you know because it forms a straight line and it passes through 0, 0. Go ahead and try to answer some questions on your own. Good luck.